So now we want to look at some more practical problems for the quadratic. So rather than just finding the discriminant and then seeing what discriminant gives us. So this time we've got a quadratic that's got an unknown of k in there. And we want to have a look at the idea that k will change, and at what values of k, for what values of k will we have different situations for the roots of this quadratic equation. So if this quadratic is going to have equal roots, now what it means there is that the discriminant will have to be equal to 0. So if we put our quadratic, we did our discriminant and on that quadratic and put that in, we were able to solve for k here. So we're able to get 36 plus 4k is equal to 0. And we've find out that k must be equal to minus 9. So there's only one value of k where this quadratic equation will have equal roots. So one value of k, because we know that must be the situation where our discriminant's equal to 0. If we get in real and different roots, well, we know that's where our discriminant must be greater than 0. So again, we set up our discriminant greater than 0, which means 36 plus 4k would be greater than 0. Solve that quadratic by taking the 36 across, and becomes minus 36, divide by 4. So when k is greater than 9, this quadratic will get 2 roots. So the x values that would take would be 2 roots if we get any number in there that's greater than minus 9. If it's just real roots, well, it's greater than or equal to 0. So basically, it's exactly the same process, except we got greater than or equal to 0, which gives us k equal to minus 9. D here, we get unreal roots. So if it's going to be unreal roots, we know our discriminant is less than 0. So again, we solve that quadratic. We'll solve this equation, which ends up being a nice linear equation, 36 plus 4k, less than or equal to 0, less than 0, which means then k is less than minus 9. We don't get any roots at all, so we won't be able to solve. So same idea, we have a quadratic here with the k minus 4 as the coefficient of x squared. So the idea is to find the value of k if this has equal roots. So again, what does equal roots mean? It means that the discriminant is equal to 0. So we take our quadratic, we take our discriminant, we set it up with a minus 2 all squared, minus 4 lots of a times c, and set that equal to 0. And we solve this, well, it's not a quadratic, it's just a linear equation, because it's just 4k. We get the value that k is equal to 3. So basically, if we can work out what we mean by equal roots, we can solve this. This time we've got the k plus 2 there, and it's got 2 real unequal roots. What does that mean? That means our discriminant is greater than 0. So we get our discriminant, b squared minus 4ac, put it equal to 0, and solve the inequality. It's not a hard inequality to solve, and we get k greater than minus 25 on 12. This time it's a little bit harder because we get the k plus 1 as the coefficient of x. So we'll see why it's a little bit harder in a moment. But if we're going to have real roots means that our discriminant is greater than or equal to 0. So b is k plus 1, minus 4 times 1, which is the coefficient of x, and 4, which is the constant. That's greater than or equal to 0. Now what we see here is that we get a quadratic in k. When we start to solve, we clean it up, we get k squared plus 2k minus 15 is greater than 0, or k plus 5 and k minus 3 is greater than 0. So basically we're looking at a quadratic here and looking at where does it give us positive values. So if we draw up that quadratic, it doesn't have to be a great graph, we know it goes through minus 5 there, and it goes through 3 there. So where is it going to be positive? Well, when all our x values are less than 5, but greater than 3, we're going to get that being those values of k making that greater than or equal to 0. So draw up a quadratic inequality, and when we've got to solve a quadratic inequality, draw a graph, draw that graph up, so you can see what from those values there will make it greater than 0. So where that parabola is going to make it greater than or equal to 0. So x squared is equal to 2mx plus 9 is equal to 0. So it's got real and different roots, means that the discriminant's just greater than 0. We sub our values in and get our quadratic. 4m squared minus 36 is greater than 0. And m squared minus 9 is greater than 0. don't do a lot of people do here and say, oh, m squared is greater than 9, so m's got to be greater than 3, and m's got to be greater than minus 3. No. If you look at any value of 0 here, 0 when you sub that in is not going to give you a value that's going to be greater than 0, because that's just going to give you minus 9. So m can't be greater than minus 3. So draw up your quadratic inequality. So m squared minus 9 gives us m plus 3, m minus 3. When we factorize it, so it's a quadratic, that's a parabola that it's concave up, going through 3 and minus 3. And what are the positive values here? Where they occur? When x is greater than 3, but less than minus 3. So we've got to be able to solve a quadratic inequality by drawing a graph. This time we want to show that this line cuts that parabola in 2 points. So if we're going to find the values of x, and it just doesn't say find the values of x, which we could, but we don't. We can do it without doing that. What we do is we solve them simultaneously, both equal to y, so we make them equal to each other. We get a quadratic there. And we make this statement. If the line cuts in 2 points, what we get is 2 different values of x to that equation, because we have to get the 2 different x values where this equation would equal 0, because that's where they would be. That's where what we have to do is solve that to find the values of x. If it cuts it in 2 points, and that has 2 solutions, that must mean the discriminant is greater than 0. So take your discriminant, we get 16, it's greater than 0. So the roots are real and unequal. So that means we've got 2 solutions to the quadratic equation. So that means it must cut in 2 points. So this time we've got this line and this parabola, and show that it cuts it in 2 points. So again, we manipulate it so we get this equational line in terms of y, and then solve them simultaneously, so make them equal to each other. We get our quadratic equation, so we said before, if it cuts it in 2 points, we get 2 solutions to the equation, so our discriminant is greater than 0. We find our discriminant, we get 68, which means that it must have, if we did the b minus b plus or minus the square root, it gives the square root of 68, which gives us 2 real and unequal roots. So 2 solutions, and means it cuts it in 2 points there. So it's a nice way to be able to prove it without actually finding the values. Show that this line doesn't touch the parabola. Well, if it doesn't touch it, so we solve it simultaneously and get this quadratic. If it doesn't touch it, then there must be no solutions. There's no solutions, we get the discriminant less than 0. Let's find our discriminant, and we get minus 15 when we put all the values in, which means we get roots that are unreal, so no solutions to the quadratic equation. So that would make sense. So see how we start to play with the idea of the discriminant, and being able to identify parts of the terms in the question, which means what our value of the discriminant must be. So whether we're going to be having it greater than 0, equal to 0, or less than 0. It's important. It's a nice way to be able to solve some questions without doing more work. So that's the whole idea of the discriminant, is to take away a little bit of work that needs to go on in some questions to actually get the results that we need.